Hey everyone, and welcome back. Today, we're diving deep into a really important topic. What does it actually mean to have a private conversation online? You know, a truly private one. And let me tell you, the answer goes way deeper than you might think.
So you've probably heard the term end-to-end encryption thrown around a lot, right? It's marketed as this magic shield that keeps all our messages safe. But I want to kick things off with a simple question. If that encryption is locking away what you're saying, what is it leaving out in the open?
Well, the answer is the absolute star of our show today, metadata. And the best way to wrap your head around it is to just picture a good old-fashioned letter. The encryption, that protects the words you wrote on the paper inside the envelope. But metadata, that's everything on the outside of the envelope. Who sent it, who it's going to, the date it was mailed, even how big and heavy it is. And you know what? That information alone can tell a pretty detailed story.
All right, so here's our game plan for today. First, we're going to dig into this hidden data problem. Then, we'll look at the two very different paths messengers take to solve it. After that, things get a little sci-fi with a look at the coming quantum storm. And finally, we'll piece it all together to define what the future standard of security really looks like.
Okay, first up, the hidden data problem. So why do we even care about what's on the outside of the envelope? Well, think about it. Even if nobody can read your messages, just knowing who you're talking to, when you're talking, and for how long can reveal an incredible amount about your life, your relationships, and your habits.
And this is the key, right here. It's the whole ballgame.
True privacy isn't just about protecting the content of your message. It's about protecting the context, too. So the real challenge for any messenger that claims to be private is making that envelope just as invisible as the letter inside it.
So how are different apps actually trying to solve this? Well, it turns out there are two completely different schools of thought. And this isn't just a technical detail, it's a fundamental split in the philosophy of trust and security.
So in one corner, you've got the centralized fortress. The whole idea here is you have one company, one server that handles everything, but you build it like a fortress, engineered to know as little about you as humanly possible. And in the other corner, you have the decentralized web, which basically says, hold on, why should we trust any central server? The goal here is to get rid of that single point of control altogether.
Okay, so Signal is the poster child for this centralized fortress idea, and they do a fantastic job. They're a nonprofit, which is huge because it means their business model isn't based on selling your data. They've pioneered amazing tech that lets you find your friends without having to upload your entire contact list to their server. They've basically designed their system to be a vault that's intentionally built to be as empty as possible.
But then you have Session, which just throws that whole playbook out the window. Here, there's no phone number, no email. Your identity is just a string of numbers and letters, your public key. And instead of going to one central server, your messages are bounced around a global network of computers run by volunteers. There's no single company to subpoena, no single server to hack. There's just the network.
And this is how they pull it off. It's called onion routing, and it's actually pretty brilliant. Picture your message inside a locked box. You put that box inside another locked box, and then put that one inside a third locked box. Each computer or node in the chain only has the key to one layer. So the first node only knows where it came from and where to send it next. The last node only knows who the message came from in the middle, but has no idea who you, the original sender, are. It's genius.
Okay, so when you lay it all out side by side, the differences become super clear. Signal minimizes metadata in its fortress. Session obfuscates it across its web. Then you have apps like Telegram, which are centralized and collect metadata. And this is a big one. They don't even turn on end-to-end encryption for group chats by default. That's a huge deal.
All right, so it feels like we've got a good grasp on things, right? We understand the landscape. But just when you think you're safe, there is this massive storm brewing on the horizon. A technological shift so fundamental, it threatens to shatter the very foundations of digital security as we know it.
Think about it. The encryption we rely on for literally everything, our banking, our private chats, it's all based on these incredibly tough math problems. Problems so hard that even the world's fastest supercomputers would take billions of years to crack them. These are the strongest digital locks we've ever created.
But what happens when something comes along that can just unlock them? A kind of master key for the entire digital world that can solve those impossible problems in a matter of hours or even minutes. Well, that key has a name: quantum computing.
So what makes these things so scary? Well, to put it simply, quantum computers don't just think faster. They think in a completely different way. They are uniquely suited to solving exactly the type of math problems our encryption relies on.
This means an adversary with a powerful quantum computer could, theoretically, go back and break every encrypted message sent today.
Okay, that sounds pretty terrifying, I know. But this isn't a doomsday story. Because the smartest people in the world, the cryptographers, they aren't just sitting around waiting for this to happen. They're already building the next generation of digital armor. They're preparing for tomorrow's code breakers today. And in fact, the good guys are already on the move. Just look at Signal. They're not waiting. They're already rolling out upgrades to make their system quantum resistant. This isn't some far-off theory. This is happening right now to protect our conversations from a threat that doesn't even fully exist yet.
And how they're doing it is really, really smart. It's a hybrid approach. Think of it like having two different locks on your front door. You have your good old-fashioned deadbolt, which we know and trust, and right next to it you've got this new, futuristic lock that's designed to stop threats nobody's even seen yet. A quantum computer might be able to pick one lock, but the other one will still hold strong. It's the best of both worlds.
So, this leads to the big question, doesn't it? We know we need to protect our metadata, and we know we need to be prepared for the quantum threat. If we take all of that knowledge, what would a messenger look like if it was built for that future, from scratch, right now?
You'd get something like this. A new gold standard, a messenger where privacy isn't just a feature you toggle on, it's the very foundation it's built on. And that is the entire mission behind a new messenger called Guardyn.
Guardyn was basically designed from the ground up to be the answer to that question. It takes the best of what we've seen, the truly decentralized architecture and the totally anonymous identity from Session, but it makes post-quantum resistance the default standard from day one, not something that gets added on later. It's built to give you complete protection for your messages and your metadata against the threats of today and tomorrow.
Because that's the whole point, right? True security shouldn't be something you have to worry about or configure. It should just be there, woven into the very fabric of the app. It should be the foundation, not just another feature on a list. It lets you just communicate freely and without fear.
And so that brings us full circle. We started this journey by asking if encryption alone really means privacy. We've seen it so much more than that. It's about metadata, it's about decentralization, it's about future-proofing against threats we can barely imagine. So the final question I want to leave you with is this. As our tools for privacy get more and more powerful, how do we make sure our own definition of what it means to be private evolves right along with them?